What if you asked AI to write a novel, but the protagonist dies in chapter 1 and comes back in chapter 5 with no explanation? Or imagine a synthetic patient record where the surgery comes before the diagnosis. Sounds off, right? That's because time matters. But here's the truth, generative AI struggles with time, and that's a much bigger problem than it seems. In human storytelling, time isn't just a backdrop, it's the skeleton. Whether it's a fictional plot or a medical timeline, the sequence of events defines how we interpret meaning. In a thriller, the tension only works if the reveal comes after the buildup. In healthcare, the diagnosis only makes sense if it's preceded by symptoms and test results. Without temporal logic, things fall apart. But here's where it gets tricky. Language models like GPT or Claude don't really understand time. They don't construct stories from a timeline, they just predict the next word, one token at a time, based on the previous ones. This works remarkably well for short content. But when you ask AI to write a long novel, generate a film script, or synthesize a complex patient journey across multiple events, that fragile sense of order starts to crack. Suddenly, characters forget what they did. Events repeat or contradict each other. Medical outcomes appear before the tests. It's like a story written with no clock, just a dice roll at every step. Let's take a closer look at healthcare. Synthetic clinical notes are becoming popular for AI training and medical simulations. But these records aren't just random facts. They follow a precise temporal arc. The patient develops a symptom. They get lab tests. A diagnosis is made, treatment begins. Then comes recovery or complications. Now imagine an AI-generated chart where the doctor prescribes medication before the diagnosis. Or the outcome is recorded before any symptoms were even reported. That's not just unrealistic, it's dangerous. Temporal reasoning in medicine isn't optional. It's the foundation of logic and causality. So how do we fix this? Let's explore two promising solutions researchers are actively working on. The first is structured event modeling. Instead of generating raw text line by line, the model first creates an event graph, a structured, time-stamped chain of what happens when. In this representation, each event contains a subject, action, and time, like patient experienced chest pain on Monday morning, or lab result, elevated troponin, 1 hour later. Once this graph is built, the model then generates the narrative around it. It's like outlining the story's logic first, then filling in the details. This approach is used in models like GLORE, Global to Local Generative Event Ordering, ACL 2022, Lee et al., and TimeLM, Yao et al. 2022, which explicitly model temporal event relationships before generating coherent long-form text. In clinical NLP, the T-BERT model by Zhang et al. 2020, also incorporates temporal event embeddings to ensure chronological integrity in clinical timelines. It separates planning from writing, just like a good author would. The second approach is retrieval-augmented generation with timeline memory. This method gives the model access to a timeline of previously generated or factual events and allows it to retrieve key temporal anchors before continuing. Imagine the model writing chapter 14 of a novel. It can look back and retrieve that 2 years ago the main character's brother disappeared, and use that to inform the current scene. Or in a patient case, it can retrieve lab results from day 3 inches to ensure that day 4's narrative is consistent. This is the core idea behind LongRAG, Long-Range Retrieval Augmented Generation, Zhang et al. 2023, and Replug, Shi et al. 2023, where the model dynamically pulls past relevant context for coherence. In medicine, systems like MedTimeline by Wang et al. 2022 use retrieval and temporal constraint checking to synthesize timelines from scattered EHR notes. These memory-augmented systems require a new mindset, not just to predict but to check and align with the past. The big shift ahead is this. We need to move from AI that merely predicts to AI that remembers, plans, and reasons. We need models that understand not just language but narrative, not just words, but time. Because time is invisible, but everything depends on it. And until generative AI learns to master time, its stories, no matter how fluent, will always feel just a little bit off. Thanks for watching. Subscribe to Incomplete Intelligence for more deep dives into the frontier of AI. Follow us and stay ahead of time.